Good evening, everyone. Welcome to another session of the Power BI User Group Italy. And this is Riccardo from Italy. And together with me today, we have a pleasure to have Marc from PAF. He will talk about process mining in Power BI. Before we start with the session, a few information about our user group site. So we are doing a session with a Teams live event as usual. You have the Q&A panel open on the right, so you can ask questions and request things to the speaker. Slides, demos, and so on are always available into our Power BI user group site that you can reach using this QR code. If you need to have all the information about our user group site, you can follow us in our social media channels. We have LinkedIn page, YouTube channels, where you can see all the recordings of our session, this one obviously, and all the past events that we had in the past. We have also the meetup page where you can find all the events that we have scheduled for the next weeks. Since we are producing many contents, we have a Power BI report that wrap up everything, like the webinars that we have produced so far and uploaded on the YouTube channel. So you can navigate to this link and see which is the list of webinars that we have by subject, for example. We have also a set of video pills that we have produced during these years about Power BI, mainly in Italian. So if you are an Italian user, you can find some quick pills about Power BI. And then if you need to work with a specific client or specific version of Power BI, we have developed a very extensive repository of Power BI installers with a lot of installers that we have collected during the years. So if you are working with a specific customer that needs a specific client, you can use our report to download. This is the final event for the 2021, and we will be back next year with new initiatives. We don't know exactly when we will start, so stay tuned in our social channels to know when the next event is. And obviously, as always, we are calling for contributions from you, so you can help us doing webinars. You can join us in our roundtables about Power BI, M language, and data in general, or you can help us during our communities event in many ways. So if you want to be part of this, simply contact us. And after that, I would like to say thank you everyone to be here, and obviously thank you, Marc, for being with us and for your time today. So I leave the stage to you. You can share your screen and enjoy everyone this session.
Thank you, Riccardo. So, ciao, mi chiamo Marc e non parlo assolutamente italiano, so scusi.
Ottimo, Marc, ottimo, bravissimo.
But actually this year, I think I was the last German who visited Italian. So now every German has been to Italy because it was my first time actually this year. And so it's an absolute pleasure after some nice weeks in Italy in the summer to actually present to you today what we at PAF do and why I think process mining is such an interesting topic that everyone should hear about, and why it is so cool that we embedded it in Power BI. So maybe some one or two words before I will start, so just to have an idea how our session will go today. So first I will present some slides and talk a bit about the main concepts of process mining and what we are doing and where we are coming from as PAF and with our product PAFnow. And after we have done that, I will jump into a live demo session where I prepared a little data set to have a small journey to a small part of our tool. And we thought about when can you ask questions, because the Q&A session is most of the time a really exciting part of those presentations. So I thought maybe what we can do is, after I've done basically showing the slides, that you have a small second to reminisce on what I've been saying. And when there are no immediate questions, then I would jump into the live demo. and then afterwards we can have a discussion and talk about the topics that you're interested in. Yes, so let me start sharing my screen and let's jump right into the slides. So as you've seen, Marc Ottenthal, I'm a data analyst at PAFnow. To be more specific, I'm a data analyst in the solution engineering team. And yes, today we talk about process mining. And the first picture you're seeing actually has to do something with expectations we have of everyday life occurrences. So in this case, we see a model of a parking lot, and for that parking lot we have an entrance, and we think, right, we know how that should work, and the car approaches, the barrier goes up, the car goes through. But as often in life, the things we imagine how things should be often, and more often than not, actually turn out quite differently. And we will jump actually back to that picture at a later stage, but I always like to have it as a cold opener, so to say, because that's a really nice manifestation of how we think things should go, processes to be more specific, and how people actually start interacting with those processes. So about PAF, let's talk a few words about what we do at PAF and why we think we are a great fit for process mining. So PAFnow actually started its journey quite a long time ago. We actually have more than 13 years of process mining journey, and we started with some consulting jobs, and our founder Tobias has been really a leader in that market. He has been engaged in many projects. And after having all of this consulting experience, Tobias thought, why not put all of this experience to good use and actually implement process mining right where the user is doing his analysis? And that's nowadays for a lot of people, it's Power BI. And before that, no one was doing Power BI and process mining in combination. And that's where PAFnow came in and basically captured the Power BI market when it comes to process mining. PAFnow is, we think of ourselves as a thought leader because we have a really narrow bonds with research and development. We have a lot of research projects together with a big German university. We are based out of Darmstadt. That's close to Frankfurt. It's like 30 minutes drive, and we have a really good university there. And so we've embarked on that journey with a background of a lot of research and development. And in the last 6 years, since we have launched PAFnow, so our process mining tool in Power BI, we've been engaged in a lot of projects, and in total more than 300 projects. So as a company, we've been recognized by a lot of those groups like Gartner, Forrester. I think we're doing a great job. We've been engaged in a lot of Fortune 500 companies. Today I'm delighted to talk about process mining and what we are doing. So on that subject, what is actually process mining? Maybe we can break down the question. First of all, what is a process? Well, a process in process mining is just an activity. Like, it has a start, it has an end, and something happens in between. So in this case, like the most high level process, it has a start, a starting point, it has 2 events in it, and it has an end point. And this is what we would call a process. And well, what is then process mining? And where process mining basically combines this ideal of processes and turns it into reality. Because let's maybe take a step back and think of how process optimization used to work. Well, before, we basically imagined ourselves a process in our little chamber because we had process experts who had really domain knowledge, and then they thought about, okay, how could a process, for example, for creating a purchase to pay process could look like. So when I buy something and I receive it, through which steps could we go? So the person thought about it and then set up a process model and then gave it out to everyone, right? And then half a year later, that person happily went to each and every one and actually had to interview them, right? Because how can I actually find out how my process went? Well, I have to ask the people that did it, right? And in our ideal world, even if we set this concept of them telling you the truth, which is not more than often not the case, because some people have some incentive to not tell you the truth, but let's say they were to tell you the truth, they would really, by their best effort, tell you how they carried out the process they were given. Then even then, most of the time, they actually don't remember those like small pesky days where the process didn't quite match the requirements. So what you then get is an ideal picture, but you never actually get to the reality. And this is where process mining actually goes in and goes right to the data. So like it skips the steps of talking to the people, which is quite tedious, it's quite costly, and it doesn't really get you anything other than like an ideal version. It gets to the data. For example, in SAP system, gets to the breadcrumbs that all of those processes leave behind in the database, and then builds out a process model based on the reality. And then you don't only see the ideal case, which obviously was there, but you also see those nifty like mishabits, like ways where the process really didn't match reality and where people needed to do ad hoc decisions, which were not be able to generalize. And that's also when mistakes happen and when costs occur for companies, because not only we are talking about the standardized processes, but also about the processes that are quite far from it. So process mining, like I just said, basically combines like this behavior of analyzing the processes that we used to have, but does it based on reality and based on real data. So you actually get the real process, and then the fun actually begins, because obviously that's just the first step, right? Getting to actually know what the process is nice, but when it gets cool is when you actually start and altering your process and optimizing, and then can go back after half a year or even after a week or in real time, and then actually see, okay, how did the process behavior change? How did, for example, my lead time change? And this is why process mining is a really interesting topic. And the other thing about process mining and why I fell kind of in love with it is because we have so many ways of how we can apply it, right? I talked about procure to pay and order to cash. Those are what we would call the bread and butter of process mining, because those are the processes which a lot of companies jump right in the beginning. But after a while, especially for companies who start with those processes, they actually start thinking about, because a process is really a topic which is in every part of a business. When it comes to production, think of audit use cases, right? You really want to, for example, in the audit environment, you really want to know about the outliers. So under which circumstances actually people circumvented maybe some rules that you had, some compliance rules. So you can think about all of those different use cases, and then process mining becomes a really lively topic, because it actually brings a lot of value, a lot of improvement to your processes. And that's why I think process mining is such an interesting topic, because even in my everyday work, I come across all of those different use cases. May it even be like crime analysis or something like this. This is like really interesting stuff, and this is what excites me, and this is the excitement I want to convey to you today. Okay, I talked a lot about process mining and high-level topics, and funnily enough, I brought you the example process. So that's what I always, when I talk about that topic, show. And funnily enough, it is a topic that I like a lot. It's pizza. And it's not only because it's an Italian Power BI meetup, but it's a topic we always bring up, because I mean everyone loves pizza. And so I brought to you the example process of pizza today. And it's a pizza with a twist. What is the twist? Well, our pizza store is digital. Well, especially in Germany, that's more often than not the case, that things are digitally in any way. Like, we are quite analog over here. So we actually brought out the fax machine recently, which brought a lot of joy, but also a lot of misery to the audience. We have a digitalized pizza place. And what can we do with it? Well, we can analyze how we made our pizza. And when we have a look on the top or on the bottom left, we see our first pizza. This is a margarita pizza. So which kind of steps did we go through? Well, first of all, at the point T1, we prepared the dough, we preheat the oven, we spread the tomato sauce, added the cheese, and baked the pizza. And this is what we call a variant in process mining. So in process mining, on a high level, we have two concepts, right? We have the individual case. So Marc is preparing his margarita pizza now, And so this is a case, but on a high level, Marc maybe prepares 10 margarita pizzas, and that's the variant. So now we have a first variant, a first basically generalized way of how a pizza should be baked. It is prepare dough, and so on and so forth. And below that, we actually have a second variant. It's the vegetable pizza. It goes exactly the same way, except we have vegetables that are added at T5. And that is now we know 2 variants of our digitalized pizza place. Okay, but what can we do with it? Well, we can create an event log, and that's actually what we need for process mining. That's the only thing we need, and that's why there are so many ways of process mining be applicable to everyday life, or what I would say like everyday occurrences. What do we need? Well, we need the case ID. So we need the unique identifier for one occurrence of something being made. So in my case, Marc made a pizza at 6:46. He started the process, and this is case ID 1. And the second thing we need is a timestamp. So that's also part of the unique identifier, right? So the timestamp obviously always depends on granularity. So granularity means in that case, maybe for a pizza, we need minutes and seconds, right? Because having just the day level doesn't really make sense. Obviously, I would know how many pizzas Marc did today, but maybe I want to know how efficient Marc was, right? So our timestamp might have to have the right granularity. And so in our case, we choose days, hours, minutes, and seconds, so that we can actually encapsulate the whole pizza process. And the third thing we need is the activity name. Sorry. So the activity name, you just seen, right? It's again, prepare dough, preheat the oven, so on and so forth. And when we have those 3 things, we can start process mining. And those, maybe even you have a data lying around, so you can actually also start process mining with those 3 information already. But process mining really gets interesting once you have additional information, because obviously now I would already know how many pizzas Marc, me, does, but how would I know who did the pizza? Maybe I have another guy, maybe my friend Kevin is also in the pizza store and he also does pizza. So now no one would even know who does which pizza and who performs better. So that's actually where additional information come into the picture. So for example, which kind of pizza, right? This is the variant, right? So maybe we could ask ourselves, okay, which pizza actually goes faster? And we could also ask about pizza size. We can ask questions like, okay, if maybe the size is a bit bigger, but we have still the same baking time, does the pizza, I don't know, gets better that way, or would we need to increase the pizza baking time? So those kind of attributes really spark your imagination. Or let's talk about price, like which pizza that we prepared was like received better. So that's also like some kind of BI questions that now come into the picture. We could also ask ourselves, okay, in which pizza store? So now let's imagine we have this pizza place downtown in my hometown in Mainz, and now I want to compare, because I'm the boss of a big pizza chain. I want to compare the place to a different store, and then I want to see, okay, how does Marc create the pizza in Mainz compared to Kevin preparing the pizza in Darmstadt? Who does it better? Who like, what is the recipient's review? Maybe is the price in some way different? How many pizzas are they selling? So those are the kind of questions we can actually start asking. And this journey only started with those 3 information and then additional attributes. And that's what process mining, why process mining is so cool. Yes. So you're seeing those 3 information, and then we have the additional information like oven temperature, size, and then we can create the process. So this was the first, let's call it the dry part. I try to make it not as dry. So I give you a moment to reminisce on what I've said. So you can ask some questions, maybe some general high-level questions, and then I will jump back to the parking lot, to the picture. You remember, right? The picture, the ideal picture of the parking lot. And then we will have a look at the data, and I prepared some kind of little journey, which we will have together. Yes.
Marc, we have 2 questions from, maybe it's not a question, it's just a comment. The first one is a comment, and say that the first image that you have shown, like ideal versus reality process, it's so true. So probably people are very used to think a very simple process, but in reality, we have a very massive process behind the scene that maybe is also in confusion, you know? So he's commenting that it's so real what you have shown with but the second is a real question saying that to summarize, in other words, process mining is to understand if a process is good enough and finding a way to improve it. So can you confirm it's a good way of defining process mining?
Yeah, I think that's a good way of capturing, right? The first step is always getting actually an as-is picture of your process, and then comes the optimization. And before process mining, we got a kind of as-is picture, and then we kind of vaguely guessed what we can do, and then we get another kind of as-is picture. So we are basically guessing how we could improve our process, but now we actually know how the process improved. So the commenter was quite right. That's the idea of process mining, and that's the start of the journey, right? Process mining has come way further than that, but those are the first two steps of process mining. That's completely correct. Yes.
Perfect. Thank you. We have no other questions for now, so you can go on.
Perfect. Well, yes, let's remember ourselves about the parking lot, the reality, the gruesome reality. And what we see here, well, it's the poor gate and some cars that went around it. And luckily for us, luckily for the parking lot owner, it snowed. A rare occurrence, both, I guess, in Germany, but also Italy, unless you live in the north, or in Germany in the south. Yeah, it snowed, and that's why we actually see car tracks on the grass. And maybe if there were a lot of cars driving around, you would also see it when it's not snowing, but for the sake of the matter, it snowed and we see that cars went around it. And we remember ourselves that we are having now a conscious parking lot. So just as the pizza example, the parking lot is now conscious about what is happening around him, and he's conscious, or it is conscious by having, for example, two gates. Well, first of all, we have a line when a car passes, right? That's the first conscious thing we do. So it tracks when a car passes, and it also tracks when the gate opens and when a car passes the second time. And so that's how we would know when a car goes around, right? It approaches the gate, so it passes the first line. It passes the second line, and the gate never opened. Case closed, right? So from that picture, we already solved it, right? Yeah, maybe not. Maybe we can find out who did it, under which circumstance, and maybe we can optimize our process. So let me jump out of this and jump into the gate showcase. So for now, we are just focusing on those three attributes, right? The case ID, the activity, and the timestamp. And in this case, we have an end date and a timestamp, but it can be also combined. It's just sake of how it is displayed. But with those three attributes, we can already do some kind of analysis. But at a later point, we will add some more attributes to it. So let's jump into the setup. So now we actually see one of the landing pages of PAFnow. So with PAFnow, we basically deliver some standardized pages which work right out of the box. When you buy PAFnow, this is also something that you can access for free. That's a link I will share later. But now we are seeing the first page of PAFnow. And let me first of all give you a small introduction of what we're seeing, and then we can start exploring a bit together. So let's focus on the right side first, because that's maybe the side with some KPIs. So on the top right, we have the duration. So that's basically the time of all of the selected cases that went by. So in our case, granularity level wise, we have minutes and seconds. PAFnow can also do, I think, microseconds and nanoseconds. So we are not quite close to that, but we could do it. But yeah, for this case, we are on the minute and second scale. And below that, we have two gauge visuals. So in the left side, we have the amount of cases. So there were 10,000 occurrences where we had an interaction with our parking lot. And the second one is the variance. So what are variance again? By variance are basically one way of how operation was carried out. So naturally, there are less variance than cases because obviously ways of an operation being carried out was done more than once. So that's why we have a lot less variance than cases. Exactly. And so below that, we have something which we call the variant filter, and it's basically listed by occurrence. It starts with the first variant. Coincidentally enough, that's also the variant we see on the picture, and then we go to the other one, and those we will have a lot of time to explore at a later stage. And below that, we have the trusty tree map. So that's obviously, as we are all Power BI users, that's something we know, and that's also something that you might notice right away. So with PAFnow, we combined our custom visuals. So we have the process explorer in the middle, and also the Power BI natural pictures or visuals that we combine to basically deliver a nice solution to the customer. And that's why you can also obviously customize it as much as you want. This is just like a recommendation that we thought can be nice for your journey. Yes, that is the right side. And on the left side, or in the heart of the page, we have also what we call the heart of our process mining solution. That is what we call the process explorer. So what do we see? Well, we see the same concept that we've talked about earlier. We see the starting point, right, and the end point, and we see some things happening in between. And what do we see? Well, we see in the first time we see someone approaches the gate, that person presses the button, he or she retrieves the card, and the gate is opened, the gate is passed, and the gate is closed. That's something that makes sense, right? Nothing too unusual here. And now what we can do, we can have a focus on the slider on the bottom. So what does the slider, or what will the slider do? Well, it will render in all of those variants, because now we are focusing just on the first variance, right? I can click on it and nothing will change. We just see here some change, but nothing else will change. So let's have a look. Let's see how this process was carried out. Well, on the second occurrence, so the second case, so to say, there was also someone who inserted, like approached the gate, inserted the card, the gate was opened, the gate was passed, and the gate was closed. And that also makes sense if you think about it, right? Because obviously when you retrieve a card, right, most likely you were driving in, right? That's where our contextual knowledge comes in. Normally in a parking lot, you, at least I think in Germany, you approach it, retrieve a card, do your business inside, and then when you leave, you pay for your card and then you insert it and then can leave, right? Nothing out of the ordinary yet. So let's see the next variant that our conscious parking lot gave us. So we also have a possibility to insert money. That's interesting, right? That's what we couldn't really derive from the picture we saw. So there are two use cases now. First of all, there are some users that can use a card. Maybe they're employees, right? Maybe they have some kind of special permit. And then there are also people who pay directly at the small computer in front of the gate. Interesting. Nothing that we can help to solve our mystery of the bad people passing the gate, but sure enough, nice information. Maybe we find out something more. Let's look at the next variant. So now we see nothing really changed, but here, let me zoom in a bit. Like this, error appeared. So this error in our tool means a self loop. What is a self loop? Well, it's just a redone of an activity, a rework, so to say. So in our case, apparently someone approached the gate and pressed the button twice. That's something that I would also do, right? When I approach, I don't know, a traffic light, sometimes I press the button twice because I think it goes faster. I don't know, sure, okay, fair enough. There were some occurrences where that happened as well. That, doesn't prove anything, but it's a nice information. Then we have the fifth occurrence. So now we have a new use case, so to say. So now we can also see that there was a way to call reception. So apparently someone approached the gate and then called reception, then left again. Okay, interesting. Nothing out of the ordinary yet, because leaving the gate, right, that was the point on the top. So that person didn't circumvent anything. I don't know. We don't know what happened. We will find out later, a small foreshadowing, but for the moment, we don't know anything about that use case yet. What do we see? Someone approached the gate, called reception, and actually someone picked up the phone. and I don't know what they talked, but the person also left the gate. Okay, interesting, sure enough. Next variant, someone approached the gate and left the gate. Okay, those people were maybe a bit shy. Maybe we can also find out why this happened. Now there are not that many variants left, so we will soon see, we have another occurrence where someone approached the gate, called the reception, talked to the nice people of the reception, and then the gate opened, and then the normal process occurs, and nothing out of the ordinary. So we have one variant left, and that should be the nasty one, right? So let's see. Someone approached the gate, passed it, and the gate and the process ended. Those nasty people. And we also see how many it was, right? It was 267. So let me jump back to the picture just for a second. So would you say we solved the mystery now? Would you say, I know what we can do? What, maybe as an open question, what would be your immediate response to that? How would you think we can solve our process? We can, rescue the process now. What could be our immediate action that doesn't happen anymore? Someone approaches the gate, goes around and then passes the gate. What could we do? I will give you a second to bring up the courage and post something in the chat, and then Ricardo maybe will tell me what you wrote.
I think there are many options. Probably we can build some walls.
Yes.
You know?
Yes,
we can build some walls.
Used to be a quite famous politician who was really into building walls, and I think he didn't really step down until recently, right? Build the wall and make someone pay for it. I don't know whom. Build it. Yeah, right? We could build a wall. That would solve it, right?
Someone else is telling in the chat, add a barrier somewhere, maybe.
Yeah, a barrier, also great, right? Maybe even throw some nails on it so they can pass, but they have the cost later, so they will know. They will tell everyone. That's even more nasty. Yeah.
Other one asking, telling, why don't we simply build a wall? Or an electrified fence, maybe.
Maybe we can build a ramp so the people, if they pass, they at least have to jump and do a nice stunt, and I can put up a camera, and then I will have some nice footage for my Conscious Parking Lot YouTube channel. Those are all valid options.
Build a barrier. So I think build a barrier is the choice that we are getting from the attendees.
Yes.
Reddy is saying, put the check in the gate closer to the road.
Could also be, right? Then when we would actually start optimizing it, right? That's also a really good tip that I think no one ever came up with it. Everyone, also me, is like, build that wall so no one can circumvent it. Yes, great options. And I think that's our immediate response, right? When we see a process not going the way we think about it, so someone circumvents whatever I thought about, I just say, build a wall higher so no one can go around. And this is a really good point, because maybe that person is right, but maybe there's another reason for that, right? So whatever that reason could be, maybe we don't even tackle that, and then we would just be mending symptoms. We wouldn't even mend the problem, and that can cause some ripple effect, right? And that's why we will now embark on the journey of finding out what happened in a lot of those cases, and maybe what we can do to solve that issue. So on the next page that I called difference analysis, we will see a lot of things that we've already seen, and we will see some new things. So the right things, right, we already seen. Lead time, yeah, fair enough. Cases, variance, also nice. Variant filters, everything is there. And on the middle, we see our trusty Process Explorer, and the trusty Process Explorer took up a new shirt. So it looks a bit different, right? It has a new mode activated, and with this mode, we will actually tackle the concept of process drift. So process drift is a concept of process mining, which basically tries to answer the questions of how a process changed over time or changed over some categoric variable. Usually time can be something else, right? So what we want to answer is basically, okay, which processes were the same and when did it change and what changed? So how can we use that? Well, we can basically go through all of those times. I will select them one by one, and we will see highlighted in a color when it actually changes, because now everything is gray. So gray basically means there was no change, but once a color appears, we will see that there will be a change. So let's look at January, right? That's January, so it will highlight green, but once I put in a second month, it will just stay gray for the moment, because it said, okay, both in January and in February, all of those processes were exactly the same, so nothing to worry about, right? Now comes in March, everything fine. April, everything fine. May, I will speed it up a bit because I already know what will happen, but yes. So this is basically showing us now on the top how many variants secured. And for now, we've seen 8 variants, and those are the variants that we already know. But what happens in November 2019? I will click it and you will see now the color yellow that arrives. And this is what I talked about, right? This is the process drift. So what we've seen is we looked at all of the months and all of the processes were the same. But in November of 2019, something changed. And this could technically be the first point where someone with contextual knowledge, so someone who was on the site, could actually know if something changed, right? I don't know what could be. I don't know, maybe there was the gate broke down or something like this, and that's why something new appeared. But would it make sense that it broke down? Could that explanation make sense? No, right? Because all of the other processes were still there, right? That color didn't change. So all of the other variants were still in existence, just a new one appeared. What could be another explanation? Well, maybe, I don't know, we got a new user group and that user group didn't know how to interact, right? Could be, I don't know. But now we've seen highlighted that there was a new occurrence, a new variant occurred, and this variant also in the upcoming months, obviously it doesn't change because in the upcoming month, there will be no more new occurrences. So we will know that this change happened in November of 2019. Okay, that's the new information that we could use, but I don't know, I'm not an expert for this parking lot yet, so I need to dig deeper and I need to dig more. And so,
sorry, Marc, can I do a question? Because I'm not understanding exactly what you are showing to us. I see that each different step in the process mining is a variant or is a variance of the process. But what is this yellow process? This which is the difference between a variance and this yellow occurrence?
Well, what this visual tries to tell us is, okay, did something change? Like, what is the change between, how does the process change in this example over time? So in the legend, currently we have time. It could also be, how does the process change between departments? So it tries to basically highlight which new variant came into the picture based on the attribute we selected. And since we selected time, we are asking which new variant came into the picture at which point. And since I started selecting November 2019, because up until here, so up until all these months, we only have 8 variants in our picture, but we will know that there's a 9th one coming, and this basically is highlighted by those bars, that there will be a new variant coming in. And when I select it, the Process Explorer will highlight basically the only variant which is different from all of the other variants. So this is what I try to encapsulate with this visual, and that's why it's highlighted in yellow. And this
okay,
is
now it's clear, because I can see the histogram on top. Now I can see that we have 8 variants until November, and then we have 9 variants.
Yes,
so we have another variant there. Okay, so now it's clear. Thank you.
Thank you for the question. Yes. So now we want to dig a bit deeper, and that's why I built the page which is called Root Cause Analyzer, which basically tries to tell us a common denominator based on our selection. So I put it really in big, and now we put in the additional attributes. So let me jump back to data raw. So now, you know, we have the case ID, the activity name, the end date and timestamp, but we basically got all of our information already out of the data, but we want more information. And this is where basically all of the new attributes will help us. So for example, we included car color, we included the car maker, we included the direction that the person was driving, the driver type, can be also interesting, right? We see employee, visitor, and we included all of this information and we put it into the root cause analyzer so that the root cause analyzer can tell us, based on our selection, what is the most likely explanation of what we are seeing. And on the right side, I've built two things. First of all, here we see lead time, sure enough, cases and variants, and we see count by bypass. So we can basically do, did someone bypass, did someone not bypass, we could select that. And here we see basically all of the activities that someone went through. So we could, for example, select approach gate, and we would just see, okay, sure, 10,000 cases. So all of the cases, everyone always approached the gate, and we see, okay, in some of the cases, someone was arriving, in some of the cases, someone was leaving. So that's not really like telling us anything. So maybe we could ask ourselves, okay, under which circumstances did someone pass the gate? Aha, there were a lot of employees, there were some driver type events. So we also know some event drivers came in. We see driver type manager, we see visitors. Sure, some nice information, but let's maybe focus on some of the interesting activities. For example, what happens or what is the most likely explanation if someone inserts money? Who is that? Aha, driver type event, 100% of the cases. So that tells us, okay, insert money apparently is only for the people that have an event. So maybe the parking lot on the weekends, is basically used for events. So they insert money. Aha, that's an interesting finding. So who presses the button? Well, apparently driver type employee and also driver type manager. So apparently this parking lot is also used by a company, and we have both employees and manager, and they are both arriving. So everyone who presses it is either an employee is arriving or a manager is arriving. So what else do we have? Well, who calls the reception most of the time? Aha, driver type unknown. Driver type post. Okay, so there's a postal service, there's a visitor, and sometimes there's a maintenance guy. Aha, interesting. What could we else do? Well, let's focus on driver type bypassed. Let's see who actually bypassed. Aha. So apparently for everyone who bypassed, for the 267 cases, right, there was a manager in a Porsche, or like a lot of times there was a manager in a Porsche. There were some managers in a white Mercedes, manager in a black Mercedes, and apparently sometimes security. So maybe the security really wanted to get fast in, fast out. That's also interesting, right? But what we also know, right, that apparently some managers are able to actually use the process as intended, because when we saw approach gate and then press button, right, there were also some managers over there. So not all managers are bad, but apparently some managers didn't really get the gist of it, right? Okay, that's some nice learnings. Let's go on the next page, and that's the final page. That's where we actually get to know a lot of the information that we've gathered. So what do we see here?
Marc, can I stop you for a question? So,
sure.
It's very relevant to the previous page, so I think it's better to have this one right now. You are showing some bubbles that if you add the values, you go over 100%.
Yes.
So someone is asking, Amedeo is asking why we go over 100% in some cases.
Let's
like
see.
This one, exactly.
Yes. So here we basically see coverage. So let's focus on coverage. You see here 81% and 19%, that would basically sum up to 100. But we also have a different dimension, which is called precision. So why do we use two dimensions? Well, coverage would only most of the time give us the right explanation, right? Because obviously based on the attribute now in this combination, driver type employee and direction arriving, we can explain 80% of the cases. But what if we could also explain the 20% of the other cases where no one pressed the button? Then that kind of explanation didn't really make sense. And that's why we added the precision. So why the numbers are above 100? Because we do a harmonized mean. So we combine coverage and precision to build a mean out of it, to basically give us quite of a strong hint what kind of explanation we could have. And that's why I choose to now switch into this explanation. So we have 4 quadrants. We have a quadrant with high coverage, low precision, and we have a quadrant with low precision, low coverage, so on and so forth. But we also have high coverage, high precision. So whenever something is in this quadrant, it's quite likely that this kind of attribute combination basically explained our selection. And that's basically why they are valued, or the values are above 100. If we were to basically exclude precision, then it would combine to 100%. But then, like the power of the explanation wouldn't be that strong, right? Because if you can explain everything by the attributes, then obviously you can also explain like the counter events, so to say. So when I basically select the counter event, like if I select everything else, like if we exclude pressing the button, then we would be able to explain everything else again. So that's why it is above 100% in combination, or it can be. In that example, not, because obviously all of the cases were that, and all of the other cases didn't have the driver type event. So we know everyone who inserted money was an event type driver and not a manager, for example.
Thank you very much.
Yes.
They are, saying thank you. It's very clear. Thank you.
Yes. So let's jump to the lead times page that I created for this demo. So let's talk a bit through what we have here. Well, we have the Process Explorer on the left, a bit enriched, so it looks a bit nicer, right? It has some color in it. What does the color tell us? Well, it tells us the amount of cases that went through. It tells us the duration below it, and it is highlighted by the duration. So it basically highlights the longest duration in the selected variant currently. And how we will select the variant? Well, we will select it here. So we see variants sorted by lead times. So lead time now in seconds. So the average lead time was 2 minutes 17 seconds, but we have some with 300 seconds and we have some with 26 seconds. We also have the root cause analyzer again, so we will have our nice explanation, and the other one are some just nice information we will not focus on for the moment, but let's focus on this one. So let's now get a bit of contextual knowledge, right? Let's select the 8th variant, and what do we see? Well, we see someone approaching the gate, waiting 1 minute and 20 seconds, calling the reception, talking to the reception. The gate opens and it took 3 minutes between talk reception and open gate. Someone passes the gate and the gate closes in 40 seconds. That took a lot of time, right? And that's not those are quite many cases, though, like 460 cases. That's already a nice explanation, right? Normally we expect like a parking lot journey not to take, what is it, like 5 minutes, right? Minus obviously the last 40 seconds, so still roughly about 5 minutes. That's a long time. That's not something that we might want to have. Okay, but interestingly enough, okay, for this variant, we have some driver type visitor, we have some driver type maintenance, and we have some cleaning personnel. So let's look at the second variant. Okay, that's the leave gate. So that's someone I highlighted in yellow. So everything that is green is basically the process that was accomplished successfully because the gate opened, the gate closed, someone completed the process successfully. Yellow is leave the gate, so the person that didn't partake in the process in any way, and obviously in the red, at the end, we see someone passing the gate. So in the second variant, the variant number 6, we have a total of 503 cases. And those were driver type post and driver type unknown. That makes sense, right? Someone approaches the gate. Again, 1 minute 20, quite a long time to call a reception, talking to the reception, and then again 3 minutes to leave the gate. That already gives us like an additional layer of information. Apparently, especially for the driver type unknown, could be that when you're approaching the gate, because let's hover over it, okay, min duration 15 seconds, max duration 2 minutes 9. So apparently it could be that it is not quite clear when you're approaching the gate, and then what do you have to do for call to reception? So maybe you're approaching this box, right, and you don't really know what to click, and maybe that could be already optimized. So because we see that's quite a long time between approaching the gate and calling the reception. And also what's quite odd, talking to reception is quite a long time. So apparently we have really a talkative reception there. And we also see that there's a min duration of 0 seconds. So apparently there's also some people who are quite quick at talking. So obviously, out of the context, what we could do, we could also do resource analysis if we had the information of who was sitting in the reception at a given time. So we could actually derive who's talking a lot to the people and who is actually doing their job. But for the moment, we don't have that kind of information, but that's just something that you could also do in process mining. So we see, okay, that also takes quite a long time, and then someone leaves. Okay, nice information. So what do we take of this? Apparently, like approaching the gate and call reception seems to take quite a long time, and talking to reception, leaving the gate also seems to take quite a long time. And we are still talking about more than 4 minutes for the process. That's a really long time, right? Let's maybe jump a bit more. What do we have here? Driver type event, right? Those were the guys and gals who inserted money. Again, we have this 40 seconds between approach gate and insert money. That could still be the case because people who are usually at an event, right, contextual knowledge, don't really know what they're doing. So apparently this takes 40 seconds. I'm inserting the money, open the gate. So this takes 1 minute. So apparently it's also, yeah, kind of quick. And also pass gate, closes gate, 34 seconds. So that's odd, right? Why is this exactly the same time? That's quite odd, right? Apparently, the gate actually always takes 34 seconds, sometimes 3 seconds, sometimes 1 minute, 7 seconds, but the gate really closes slow. And that really slows down our process, and it slows down our process at least by 34 seconds on average. And if you have like 2 cars behind each other, then obviously it doubles, right? Because the car behind has to not only wait for the gate to open in 34 seconds, but also to close in 34 seconds. So that's quite interesting, right? So apparently our gate is really slow. Aha, interesting, right? So that now the picture gets more clearer. Apparently the process is quite slow, and there are several reasons for that. We have like a talkative receptionist. For those guys and girls, we have a really slow closing gate. And also apparently the box that we have to insert the money is also not the fastest on this planet. But let's look a bit more. Can we find out some more? Okay, this was the case, right? Where we have drivers and employees. So 1,190. So approach the gate, presses the button. Aha, those were the people that pressed the button a lot of times. And by now we actually know why, because it just takes so long. You just are in front of it and press the button because you're so desperate of getting to work that you just can't take it anymore. And that was the case for some people that pressed the button a lot of times. And actually, apparently that also like prolonged it because this took another additional 20 seconds. So that didn't really help. But yeah, well, what can you do? Again, we see the same thing, right? Approach the gate, press button, like pass gate, close gate. It's again, it's like 35 seconds. So it's again, a really slow gate. And what we also see is that apparently if you have the contextual knowledge of someone going in and out every day, the process on the box is quite fast. So maybe the box itself isn't the issue. It's maybe the UX that is inside of the box, that when you approach the box and you're not sure what you do, it takes way too long. So apparently whatever is how the interface of the box is mapped out is clear to everyone who already has been there, but not clear to a lot of people who've never been there. That's also really nice information that we can use to optimize the process of our gate. Let's go to the first variant. That is the variant with the most cases. This is the 2,449 cases for a lot of employees. So in this case, let's hover over it. For 1,992 cases, there was an employee involved, and 457 cases, there was a manager involved. And also, we see here, really, it's just, I sound like a broken record. 40 seconds, so the gate again closes slowly, but we are otherwise quite quickly, I would say. So we're otherwise quite quickly through the process. So those people know what they're doing. They're really experts at parking lot bypassing, or not bypassing, but using the process. And again, we have the slow closing gate. Let's jump maybe to the 5th variant, because the 2nd variant is just exactly as the 4th one. We have post and unknown, and those are the ones that approach the gate, call the reception, and then leave the gate. And apparently, again, approaching gate, call reception, we see again, especially for the guys and girls from the driver type unknown. Apparently, that's a quite slow process. And this is something we will have to work on, right? We have to make it more clearer what to do when you approach the box, because for some people, they just don't know what they have to do when they approach it. And now for the grand finale, we have variant number 9. And this is the variant where people, both the security and in 195 cases, the driver type manager, bypass the gate. And by now, at least to me, and I hope also to you, it became quite apparent why people could be driven to such madness as to bypass the process. Because maybe it wasn't the reason why they didn't want to pay money, because driver type manager and also security never had to pay money in the first place, right? So it's really not the case of getting some economic benefit, right? It's just that this process just takes so goddamn much time that people just don't want to mess with it. They are fed up with the process. And that's why they approach the gate. They say, yeah, I don't want to have any of it. I'm just going around it. Apparently they go around it quite slow, so 24 seconds, and then they go through it. And that's basically, and here I want to basically wrap up, that's something interesting, right? Because what did we see? Well, we saw that people didn't want to take up with the process, and I thought, as someone who thought of the process is perfect. And when someone bypasses it, it cannot be. But now we learn from the data, from the as-is process, what was the reason behind it. The reason was not that the process was not set up in a way, it was that the parts of the process were faulty. There were parts that we could improve to basically set up the process in such a way that people at least somewhat enjoy interacting with it. And this is my last words, at least for before we do the Q&A session. Thank you very much for listening. And yes, let's open the Q&A part.
Thank you very much, Marc. You have answered many questions also during the session. That has been very, very funny, to be honest. It's been you have explained quite complex topic, I think, but in a real clear way. So thank you very much for that. We have 3 questions left in the chat. I would summarize 2 of them in one, saying, can you talk a little bit about licensing? We know that PAF is not free, not all free, maybe. So you can talk a little bit about licensing, and if all the visuals that you are showing to us today are included in the license.
Mm-hmm. Sure. So I would talk 2 points about it. That's why I have this slide. So I will also share this link with you, but you can also type it up. It's bit.ly/freevisual. That's basically, I can also show it to you here. If you say get more visuals, and if you enter here, I think PAFnow, then you will get the Process Explorer. So everything you've seen here today, you can also do yourself at home with, it's this one. Everything you can do, you saw it today, you can also do at home, free of charge. So you can also already dive into your process analysis. I think there are up to 5,000 events included. So you can already put a lot of into it and then start your journey. And all of the other visuals we've seen today were basically from Power BI. I think the lead time, we do some kind of shenanigans, but you can somewhat also do it with a card. But everything else, and the root cause analyzer, unfortunately, is not included in that. But yeah, the Process Explorer, which is what we call the heart of process mining, you can already try out with the case ID, the timestamp, and the activity name. And for the second part of the question, well, first of all, I can obviously always tell you to talk to my good friend at PAFnow, Marvin Sinsheimer. That's an email I can provide to you afterwards. But he said we have a starter package because we are more targeted towards companies. That includes 3 editors, 2 viewer concurrent, and cost 36,000 euro per year. So that's the license model. And when we talk about licenses, there are 2 things that we can do. Well, first of all, we have the companion. That's what I had running in the background. It first of all basically proves like checks that you have a license, and you can also do the transformation because once you acquire the license, there are a lot more visuals, and you already see here there are a lot more visuals, and you can maybe check out some of our videos online. A lot more visuals that you can access, and there are a lot more standardized pages that you will access. So those are the licensing model behind PAFnow, and those are the things that you can start right now, but also have a chat maybe with Marvin, and then get into how you can try it, because we offer a free trial run for companies that are interested. So you can try it out 4 weeks for free. Then you will actually have the pleasure of talking to me, because that's basically what I do. Also do during the day is go with companies, and together we explore the solution with their data. And in a 4 weeks free trial run with some consulting from me and from my colleagues.
Thank you very much. Very comprehensive answer. Thank you very much. There are some compliments in the chat. Very interesting session again from our attendees. And one question left. What happened from November onwards to cause the uptick in bypass? So in your scenario, Reddy noticed that there's an uptick in bypass in November.
So what happened? We don't know from that, because obviously what happened is we had this new variant, right? There were 8 variants and now there's 9. And that would now be a follow-up questions that we have to ask. So what we could do, obviously we have not this contextual information, but what we could do is we could do a resource analysis. So normally in our standard process, we have resource R, we also have it here. So what we could do is we could pull in resource and actually see, I don't know if that's in the data, but let's check. I think it's not. No, it's not. So if we were to use pseudonymized data, and then we could actually see if we have that information, who was it who actually bypassed? We could check if that person maybe joined the company recently, or it was maybe a person that was in the company all of the time and just was fed up in the process. So it kind of depends what the question is. If we are talking about who, then we might need some more information, or we can contextualize the information based on the driver type and the driver car type. So to say, maybe you know that a black Mercedes is just driven by one manager, then you kind of know who did it. But yeah, that's a question that you would have to follow up on this point. Yeah. I think you're muted.
Yes, I'm sorry. Yes, thank you very much. You have answered to all the questions during the session. So it's as I said, it's been a very interesting session and funny. You done very good job. Thank you very much. It's been a pleasure having you today with us, and it's been a pleasure seeing this very interesting session. We will publish this on our YouTube channel, so if people didn't manage to see the session live, we'll see the recording. So thank you very much, Marc. It's been a pleasure. Danke. And I would say to all our attendees, goodbye. Have a nice vacation, have a nice Christmas and Happy New Year. And we will see next year. So stay tuned on our social channels to see which are our plans for the 2022. Take care. Bye-bye.